Greetings, secondary educators to be. In this screencast, we talk about functions and we talk about images and pre-images of sets under functions. We'll present some examples. It won't be too bad, I hope. Fingers crossed. Here we go. Let's deal with the idea of a function. And surely you have done the activity where you talk about what a function is in your own mind. If not, hit the pause button and remind yourself what you think a function is, how you would explain that to a teenager, and then we'll do the thing where we remember that we studied Math 239, and so we're supposed to know this. All right, so we're going to let A and B be non-empty sets, and we're going to let S be any subset of A cross B. That's the Cartesian product of A and B. That's the set of ordered pairs where the first element comes from A and the second element comes from B. We say that S is a function from A to B if for every A in A, there is exactly one element of S whose first entry is A. There's a few things I want to say about this. S is a function. S is a set of ordered pairs. A function is not a rule. A function is not a table. A function is a set of ordered pairs. Even when we graph something like this, the function is the set of ordered pairs. A function is always a set of ordered pairs. The other key word here is exactly one element. Exactly. There is one. There is only one. So every element of the domain maps somewhere, and every element of the domain maps only one place. Fair? We call A the domain. We call B the codomain, but nobody talks about codomain in high schools, not very much anyway. So what do we mean when we talk about the range of a function? The range of a function is f of the set A. That's the range. When we talk about range, we mean f of the set A. And this means the image of A under F, or if you like, the set of elements B in big B for which f of A equals B for some A in A. That's what we mean when we talk about the range of a function. So the range is always a subset of the codomain, always. This is an understanding that carries over with us from Math 239. And so in Math 239, you did some example like this one. We're going to let f be a function from the reals to the reals, and f of x is going to be the absolute value of x, and we're going to let the set S be the set -2, 0, 2, and 1, just because 2021 feels a little negative so far. And we're going to find something. This video is not going to make any sense in 3 years. Not at all. Take a moment figure out what f of s is, figure out what the preimage of S is, those elements that map to this set, what it means to talk about the image of the preimage of S, and then the preimage of the image of S. Take a moment, hit the pause button, see if you can come up with those answers, and then in a few seconds, they will magically appear with brief commentary. Well, hopefully you were able to do something with that before I threw these answers up here. The image of the set S, all of the outputs if these are the inputs. We can write those in any order because it's a set. Sets are unordered. So we could write that in any order. We write those three numbers in any order. Same with these five numbers. These are all of the numbers that map to something in this set. Uh, this is the images of those numbers. So all of these, oh, really? All of these numbers map to those. The negatives map to positives. The positives also map to positives. And then the preimage of those sets. So all of these numbers are the ones that map to those. That's the way that goes. Uh, why don't these match? Shouldn't these match? Well, they match under the circumstances where your function is a bijection, and that's another screencast, but this is not a bijection, so those sets don't necessarily match. Hopefully these are things that you're familiar with from times past. Hope that things are well with you. We'll do one more screencast in this lesson, and then I can't wait to see you in class.